Hello everyone, my name is Praful John and I'm a student of International Institute of Professional Studies DAV Indore. Currently I'm pursuing Masters in Technology in the field of Information Technology. This video is part of my assignment which contains solution to test number 3 which was conducted by Dr. Shaligram Prajapat sir.
The questions asked in the video were the following. The first question which was asked was, how do authentication methods such as public key cryptography protects against attacks such as man-in-the-middle and replay attacks? The answer to the question was,
Public key cryptography protects against man-in-the-middle and replay attacks by using digital signatures and PKI and key exchange protocol to ensure the authenticity and integrity of messages exchanged between parties. By using these methods, attackers are unable to modify, intercept, or replay messages without being detected. So, here how it is done. First, we will be discussing about digital signatures. So, public key cryptography allows individuals or organization to use a pair of keys, a public key and a private key, to encrypt and decrypt data. Public key is used to encrypt the data, and corresponding private key is used to decrypt the data. A digital signature is created by using the sender's private key to encrypt a message digest, a mathematical summary of the message, which is then appended to the message. The recipient can use the sender's public key to decrypt the message digest and compare it with a locally computed digest to verify that the message has not been tampered with in transit while it was transmitted, right? This ensures that the message is authentic and has not been modified by an attacker. The second method is public key infrastructure, which is as follows. PKI is a system that provides a framework for issuing, managing, and revoking digital certificates that contain public key. The next question we have was, how can side channel attacks be used to extract information from systems that are designed to be secure, such as encrypted communication or hardware security modules? The answer is follows. Side channel attacks are a type of attack that can be used to extract sensitive information from systems that are designed to be secure, such as encrypted communication or hardware security modules. These attacks take advantage of unintended side channel leak of information, such as power consumption, electromagnetic emission, or timing information. Here are some ways that side channel attacks can be used to extract information. The first way is power analysis attacks. By analyzing the power consumption patterns, an attacker can extract the cryptographic keys being used and use them to decrypt encrypted data. The second attack is timing attacks. By analyzing the timing information, an attacker can deduce information about the cryptographic key being used. The third one is electromagnetic attacks. By analyzing the EM emissions, the electromagnetic emissions, an attacker can extract information about the cryptographic keys being used. The fourth one is ejection attacks. By analyzing the system's response to these faults, an attacker can extract information about the cryptographic keys being used. So to mitigate the risk of side channel attacks, several measures can be taken. The first measure is implement countermeasures. Countermeasures such as masking or blinding can be used to hide the sensitive information from side channel attacks. The second one is implement hardware security features. Hardware security features such as tamper proofing or shielding can be used to prevent attacker from physically accessing the device. The third one is limited access. Limiting physical access to the device or the cryptographic key can help prevent attacker from carrying out side channel attacks. The fourth one is implement randomization. Randomizing the cryptographic operations or the timing information more difficult for attackers to extract information from side channel attacks. The fifth one is regular security assessment. Regular security assessment can help identify vulnerabilities and weaknesses in the system, allowing for timely measures to be taken to mitigate the risks. The third question is, in what ways can biometric authentication method be vulnerable to attacks such as spoofing or replay attacks, and what measures can be taken to mitigate these risks? The answer is, Biometric authentication methods such as fingerprint scanner or facial recognition system can be vulnerable to various types of attacks, including spoofing and replay attacks. Spoofing attacks involve using fake biometric data to trick the authentication system into granting access, while replay attacks involve recording and replaying previously used biometric data to bypass authentication. Here are some ways these attacks can occur. The authentication attacks can occur when an attacker presents fake biometric data to the authentication system. For example, an attacker might create a fake fingerprint or mask to spoof a fingerprint scanner or facial recognition system. The second one we have is data interception attacks. In data interception attacks, an attacker intercepts biometric data being transmitted between the users and the authentication system. The attacker can then replay this data to bypass the authentication system. The third one is template attack. Template attacks involve stealing or creating a template of users' biometric data. The attacker can then use this template to generate fake biometric data to spoof the authentication system. To mitigate these risks, several measures can be taken. Some of them are the use of liveness detection. Liveness detection can help prevent presentation attacks by verifying that the biometric data being presented is from a live person or not a fake person copied biometric data. The second one is encryption. Encryption can help prevent data interception attacks by protecting the biometric data as it's transmitted between the user and the authentication system. The third one we have is use multiple factors. Using multiple factor of authentication, such as combining biometric authentication with a password or PIN, can make it more difficult for attackers to bypass authentication. The fourth one we have is regular updates. Regularly updating the authentication system software and firmware can help prevent template attacks by introducing new features and fixing vulnerabilities. The fifth one we have is conduct security assessments. Regular security assessments can help identify vulnerabilities and weaknesses in this authentication system, allowing for timely measures to be taken to mitigate the risk. This video was the solution to the test paper 3. I hope you learned something from this video. Thank you so much for watching.